Your brain expects physics to behave one way, but these experiments do the exact opposite. Everything you're about to see is real, no CGI, no tricks. Just real experiments that feel impossible until you look closer. Let's start with this. It's a heavy metal ring. Drop it and gravity does its thing, simple enough. But now, watch what happens when we drop it through this copper tube. It slows down, floating, almost defying gravity. This isn't a magic trick. It's a powerful physics principle called Lenz's law. As the magnetic ring falls, it creates changing magnetic fields inside the copper pipe. These fields generate their own electrical currents, called eddy currents, within the copper. According to Lenz's law, these currents create an opposing magnetic field that pushes back up against the falling magnet. This magnetic resistance is what we call electromagnetic braking. It's the same technology high-speed magnetic levitation trains use to stop smoothly. So while it looks like the ring is just hanging in the air, it's actually caught in a powerful, invisible magnetic battle, slowing its fall to a crawl. It's a perfect visual of how unseen forces are constantly at play. It's a real-life physics illusion that shows just how weird electromagnetism can be. It's not just a falling ring, it's a demonstration of forces that shape our modern world. Next, let's play with fire and water. What happens when you drop water onto a surface that's incredibly hot, way past the boiling point? You'd expect it to hiss and evaporate instantly. But instead, something amazing happens. The water droplets dance and skitter across the surface, floating on a cushion of their own vapor. This is the Leidenfrost effect. When the surface is significantly hotter than water's boiling point, the bottom layer of the water droplet instantly vaporizes upon contact. This creates a protective layer of steam that insulates the rest of the droplet from the hot surface. This vapor cushion dramatically reduces friction and heat transfer, allowing the water to levitate and glide around for a surprisingly long time before boiling away completely. It's a real science illusion, water floating on heat, a beautiful physics heat experiment right in front of your eyes. You can see this happen in your own kitchen if you flick water into a very hot pan. It's not just a cool party trick. Understanding the Leidenfrost effect is crucial for things like cooling nuclear reactors and even designing more efficient engines. It's a reminder that sometimes extreme conditions create their own rules. Now, let's move from heat to motion. You've probably spun a coin before. It wobbles, spins faster and faster, and then clatters to a stop. But what if it didn't? This is Euler's disc. It's a heavy, precisely machined chrome-plated steel disc. When you give it a spin on a smooth, slightly concave mirror, something mesmerizing happens. As the disc loses energy, its edge rolls along the surface. Instead of just stopping, the rate of precession that's the wobble speeds up dramatically. The sound it makes climbs in pitch, creating an eerie, accelerating hum that seems to go on forever. It feels like time itself is speeding up for the disc. This isn't a time illusion, though. It's a beautiful display of rotational motion and the conservation of angular momentum. The disc finally comes to an abrupt, sudden halt when the air trapped underneath can no longer support it. The energy is dissipated through both friction with the surface and the sound waves it generates. The Euler disc physics demonstration is so captivating because it visually and audibly stretches out the final moments of motion, making it feel like it's breaking the rules of time. It's a spinning coin illusion taken to the absolute extreme. Let's switch gears to the world of fluids. Look at this stream of water. It looks completely frozen, like a glass sculpture. You can even touch it and it feels solid, but your hand comes away wet. This isn't frozen water, it's a perfect example of laminar flow. In laminar flow, the fluid in this case, water moves in smooth, parallel layers with little to no mixing or disruption. Every particle of water is following a straight, predictable path. This creates the illusion that the water isn't moving at all. But if we introduce a little turbulence, the illusion shatters and you see the chaotic, splashing flow you're used to. Now, let's take it a step further. By placing an object, like a sphere, directly in the center of this smooth water stream, we can create another stunning phenomenon, the water bell experiment. The laminar flow drapes over the sphere perfectly, forming a thin, stable, bell-shaped sheet of water. It's a breathtaking visual of fluid dynamics, showcasing the elegant and orderly side of nature. It's a reminder that even something as common as water can behave in ways that look utterly alien when the conditions are just right. This smooth water physics is a testament to the hidden beauty in fluid motion. Finally, an experiment you can't see, but you can definitely feel. Watch as I puff out a ring of smoke. It travels across the room, stable and defined, holding its shape, but the smoke is just a marker. The real magic is the invisible structure it's riding on, an air vortex. This is a smoke ring vortex. When air is pushed quickly through a circular opening, the air at the edges is slowed down by friction, while the air in the center moves faster. This difference in speed causes the air to curl back on itself, forming a stable, donut-shaped rotating structure called a toroidal vortex. This vortex is incredibly stable and can travel long distances, carrying the smoke with it. You can even see two vortices interact, bouncing off each other like solid objects. This is fluid dynamics of the air in action. What's amazing is that these invisible physics experiments are happening all around us. The wake of an airplane creates powerful wingtip vortices. Even the way your heart pumps blood involves similar vortex dynamics. The smoke ring is just a simple, beautiful way to visualize these powerful, unseen forces that govern the air we breathe and the fluids that move around and within us. It's a powerful glimpse into the invisible architecture of our world. Reality doesn't always behave the way we expect. From magnetic fields that defy gravity to water that floats on heat and invisible forces that travel through the air, these experiments show us that there's always more to learn. Which experiment broke your brain the most? Let me know in the comments. Thanks for watching. Subscribe for more reality glitches.